David Palandro, marine biologist.
My name is Emma Stacy and I'm a chemist.
I am Dr. Asad Zidan and I am a physiology professor.
Hi, my name is Amma. I am a surgeon.
My name is Istarma Harik. I am a dentist and I work in Germany.
Hi, my name is Evan Wesley, and I am the Vice President for Student Activation for Third Project.
Hello, my name is Sarwat Al-Juti. I'm a neurosurgeon and working in Germany since 8 years.
Hello, everyone. Welcome back to another episode of our podcast, The Universe is Made of Stories, Not Atoms. Today, a special guest is joining us, Miss Emma Stacy, who is an ecotoxicologist who works at the US EPA.
Hello. Hi, Emma. We're really happy to have you on here. And, this is the first time we've had a ecotoxicologist on our podcast. So this should be really interesting. I wanted to start off by asking you about your sort of like what led up to you choosing your career. And so, my first question is what does a typical day at your job look like?
Yeah, so a typical day, I usually spend most of my time in the lab, in the wet lab. So currently I'm working on detecting thyroid hormones in thyroid gland tissue. And the procedure is pretty finicky, so it does not work very well. So my typical day would be going into my office, sitting down, trying to make a research plan for the day. So I do that by looking at papers where people have maybe done similar methods, and chatting with coworkers to get their advice. And then I develop a plan of okay, these are the things that I'm going to change in my procedure to try to make it work better. And then I take that into the lab and I do the procedure a little bit differently every day. And then I check the results to see if the things that I had changed had worked better. So right now, that's my typical day.
And that sounds really cool. It sounds very change. Yeah, it seems very flexible. You kind of get to choose what you get to do during the day based off of what you need to do. Is that?
Yes, definitely. Yeah, it's very self-motivated, self-led, and also collaborative with my coworkers. So, a lot of people think of science kind of as this mad scientist phenomena of a person that's really smart, goes into the lab and just does what needs to be done all on their own. But in actuality, it's just normal people who don't, they're as baffled by the errors as anybody else, and they talk it out with their coworkers, and it's very collaborative and supportive.
Yeah. And does it ever, I think it does, but does it ever get frustrating because of the of not knowing what went wrong and how to fix something like that?
Yes, it definitely does get frustrating. I think especially as a younger scientist, I and my other young coworkers get frustrated more because obviously it's a part of science. And so the older people that have been there kind of have learned how to handle it and maybe not get so overwhelmed and frustrated because it is a part of everyday science. But yeah, I've definitely gotten pretty frustrated before because things in your research and in your talking with colleagues, you're okay, this makes sense to me. I understand why this is happening. So if I do this should happen. And then it just doesn't. And you're why though? It should. So yeah, it is really frustrating, but at the same time, really rewarding when stuff does work out, because obviously that's the natural conclusion of working through stuff that's frustrating is you finally are oh yes, it worked and I get it. And this feels awesome.
It's just all part of, that scientific process. You have to adapt to different challenges that come up.
Yes, exactly.
So we kind of wanted to go a little further back and ask you if you've always been interested in chemistry.
Yeah, I actually haven't always been interested in chemistry. Not that I wasn't interested in it, but I've I wasn't the kind of person that's like, oh, when I was like 7 years old, I knew I wanted to be a scientist. That definitely wasn't my path. I was more into humanities for the longest time, pretty much until high school. But I was always interested in the environment. So I was very went to pick up trash on my free days as a kid. It's like I wanted to clean up the environment, and I, interested in the environment and stuff like that, protecting it. But it wasn't until high school that I realized that I liked science. And that was mostly because of my sister, who at the time was in her freshman year of college and was taking a chemistry class and was telling me about how cool it was and how she was really good at it and really liked it. And I was like, oh, that sounds cool. I should do stuff like that. So that summer I went to a summer camp at her college for science.
Yeah.
And I really fell in love with it and the scientific process and learning about how things worked. So ever since then, I had been interested in science.
And have you, when did you realize you wanted to specialize in toxicology?
Yeah, that was later on in college. I actually went into college being pre-med because I didn't really realize how many scientific career fields there were. So I was like, oh, I'm interested in science. So that means I'll be a doctor. I didn't really think about it. So I went in thinking I was going to be pre-med, but then realized I did not like working with blood or anything that doctors do.
Yeah.
So I started branching out in my sophomore year to find other areas of science that I would be interested in. And I took an environmental chemistry class. I don't remember if it was sophomore or junior year, but it was later on. And I really liked it. And I distinctly remember we were assigned a paper that was states of pesticides in the environment. So you would choose a pesticide and track where it went over time and how it degraded and stuff like that. And I thought that was super cool and also kind of scary because some of them are pretty toxic and remain toxic and get in all areas of the environment. And so I was I think it'd be really cool to try to work to mitigate the effects of some of these harmful chemicals. So that's what I did.
And then this is more of a question that we were just curious about, but we were wondering if are analytical chemistry and toxicology similar or the same, or is toxicology a subsection of analytical chemistry?
Yeah, so analytical chemistry is just the tool that you use to verify the environmental chemistry.
Yeah.
And it's a tool that you use to verify a lot of different areas of science. So really every area of science is dependent on analytical chemistry.
Yeah.
Because what it is just you using instruments to measure the concentration of chemical that you have. So for example, when I'm measuring the thyroid hormones, the toxicology part would be the brainstorming of what effects certain chemicals are going to have on increases or decreases in the thyroid hormones to predict the amounts, and then obviously the process of extracting them. But the analytical chemistry is actually putting the samples on an instrument that will measure the concentration of those samples.
That sounds very complicated.
It does. I was trying to follow along and I think I got lost somewhere.
Sorry, I'll try to break it down in a simpler way. Analytical chemistry is just measuring of chemicals. So it's not toxicology, but it is related and it is necessary for toxicology. So I'm an analytical chemist at the EPA. Technically, that's my title.
Yeah.
And so there are a lot of experiments that I'm not directly involved in, but people will give me samples and be like, okay, this is what my sample is. Can you tell me what is inside of it? So that's kind of the analytical chemist's job, is to say okay, you have 5 micrograms per liter of atrazine in this sample. So without analytical chemistry, you would not know that. You'd just be guessing.
Yeah. Okay. That makes more sense.
Okay.
Going back to, you mentioned like how you found your interest in toxicology in university. So we found that you went to Scripps College, which is an all-women's university in the US. And we were just like curious about that because I mean, it's not often that you hear someone with an all-women's university, at least like for me personally. We were just curious about like your experiences there, and do you regret going to an all-women's university instead of a mixed one? Like, would you recommend it? And
yeah. So my university was a little bit different than other women's universities because there is a consortium. So we had our all-women's college, but then there were 4 other colleges that were basically on the same campus that were co-ed. So I didn't have my science classes with only women. It was mixed, but it was a good experience because it made the distribution of gender more equal, because a lot of times in science classes, they can be mostly male. And so having the women's college that was mostly women increased the percentage of women in those classes. So it made it feel more balanced and more equal. Whereas like maybe at a co-ed college, I would have felt like I was the minority, which would not be fun.
Yeah.
So it was definitely really helpful in like boosting my confidence. So I really liked that aspect of it. I definitely don't regret going to one.
Yeah.
Yeah. And I think even if I went to like a fully all women's college, I think that would have been good too, because just like being around people like yourself is always inspiring, and like be like, oh, like if they can do it, I can do it type of thing.
So I mean that was touching a little bit about your experience during college, but we wanted to ask if, you know, going to an all-women's college affected the connections that you made after graduation, because if your connections were mostly women, and we kind of have this understanding that women have sort of a lesser presence in STEM, unfortunately. So do you feel like that affected the connections that you were able to make after you graduated, or do you believe that it did not?
I don't think it affected it, no. I mean, I didn't really do a lot of like networking stuff. I think science is less dependent on that. I know a lot of my friends who maybe are in like finance fields or like other humanities, like they're more dependent on making connections, but science is, I think, less about who you know. So I just got this job because I saw it online. So I didn't use my college connections to get this current job at all.
Oh yeah.
But I think even if I were to rely on the connections from a women's college, I don't think it would have hurt me, because I mean, biology as a field, I don't think is really male dominated anymore.
Yeah.
Maybe like the older people at lab are mostly male, but the new generation of scientists, I think, is very equal, at least in biology and toxicology. Maybe even, I think biology is a majority women in a lot of places now. That's not to say that chemistry and physics, I think those two fields are still very male dominated and kind of have toxic mentalities, but I'm not in those fields, so
yeah,
that is good for me. So yeah, I think a lot of the new generation at my lab is a lot more equal in terms of gender, race, things like that. Again, a lot of the older people at lab are white men, but things are changing pretty quickly, so good.
I mean, I hope our viewers, like at least our like young teen girls, like find that inspiring and I guess encouraging to go into the scientific field, because I guess it can be a bit daunting sometimes because of that, like that it's like a male dominated field.
Yeah. I think it's important to know that that is not always true, and that even in chemistry and physics, things are changing. So yeah, don't lose hope.
That's really nice to hear.
We know that you went to the University of Edinburgh, I believe, and it's a mixed school. So was that experience kind of maybe jarring after going to an all-women's school, or was it like kind of a whatever shift?
It definitely was very different, but not because it was co-ed. Because like I said, the consortium provided like multiple genders for me in undergrad, but then the graduate experience was different because, I mean, it was in a different country, and then also it was a bigger university by far. So my undergrad was pretty small. It was like 6,000 people. And then the University of Edinburgh was like, I don't even know, huge. So that was definitely very different feels just because of the size and being in a different country. So yeah.
For sure.
I'm sort of wondering, like I don't know if this is like sort of a personal question, but what was the reason that you wanted to, pursue higher education outside of the US? Was it deliberate or like the best opportunity at the time?
Yeah, it was definitely deliberate. I wanted to live outside the US because I hadn't really gotten that opportunity. Like, a lot of people study abroad in college, but since I was a swimmer and did science, I didn't have a lot of time. So I kind of like wanted to get that experience. So it was definitely like, that was my main drive of even getting a higher degree, is I was like, I want to do something outside the US. Like, what's the best way to do that? I guess I'll like get a master's. But it turned out to be a good idea and a good experience. I think masters definitely will not get you as far as a PhD, of course, but when I started out my current job, I think it makes you more competitive when you're initially applying to jobs. I don't think it matters much after the first year, but it definitely, I think, helped to get the job I currently have.
Yeah. And so then, do you think that you would like to like work in the future outside of the US?
I ideally would like to. I think that would be really fun and different, but it's really difficult to do unless you have like a very unique skill set and you can like prove that there are other people, or there aren't other people in the country you're trying to go to that have that skill set. It's really difficult. So I've kind of looked into it, but yeah, like most places are just like, oh, if you're not a citizen, don't apply type stuff. But I have a friend that has a PhD that recently moved to the Netherlands. So I think it's like easier if you have a PhD to like move between countries, but otherwise it's like, it's pretty difficult, unfortunately.
Are you considering getting a PhD?
No, not for me. It's a lot of work with not a lot of pay. So that is a big downside for me. I know a lot of people currently getting their PhDs and they're just stressed all the time. So like what I have heard and what I personally have concluded is if you're not like fully 100% dedicated to the idea of like doing the science that you're doing, or if you're not fully dedicated to like getting a job that requires a PhD, like it's really hard to stay motivated through that. And the job that I want to do doesn't require it. And so there doesn't seem to be much need for me to do that.
Well, since we're already on the topic, and as still high school students, we don't really know much about that process of like the master's and PhD stuff. Like, why do you say that getting your PhD like means lower pay? Is it because like while you're getting it, you're not working, or? Oh,
I just mean like while you're getting the PhD. PhDs take like, in the US, they take about 5 years. Sorry, go ahead.
Oh, I just said like 5 years. Like, I didn't know it was that much. I thought it was like 2 years or something.
Yeah.
No, yeah, it's a long time. If it were 2 years, I would do it.
Oh, yeah.
But no, they take a really long time and they don't pay very much. Like, so getting your PhD, you get like a stipend. So you're working while being a student. So they pay you to like be doing your lab work, even though you're like learning through it. But they pay you like minimum wage in a lot of cases, I think. And so forgoing 5 years of like an actual salary for 5 years of like barely scraping by while you're like the most stressed you've ever been in your life. Just doesn't sound that appealing to me. It is to some. I don't want to like discourage you from getting a PhD, because if you have a job in mind that requires it, then it's like, I think not as hard to push yourself through that. But if there's not a very defined reason that you have, it's very difficult. And I don't have a reason, so I don't want to do it.
I think that's a very reasonable way of thinking. Like, sometimes you have to weigh out the pros and cons of doing things, because like at face value, a PhD sounds like really fancy and everything, but when it comes down to it, it's like, okay, will this benefit me more than it will harm me? And I think, I mean, is that what you're getting at?
Yes, definitely. Because I know it would like benefit me, and it would be a good experience in some ways. But yeah, the benefits are not there for me. So
all right, we want to kind of shift now back to toxicology. So some background information for our listeners. I know you already kind of touched on all of this, but the field of toxicology helps us understand harmful effects that chemicals and substances might have on people or animals or the overall surrounding environment. Toxicology also allows us to predict what and how chemicals may cause harm, and then shares that information to sort of protect public health. As we did research, we kind of read that toxicology is divided into 3 groups: environmental, economic, and forensic. And you've told us that you're an ecotoxicologist, but do you still work with and collaborate with people from all 3 groups, or is your, sort of your daily interactions mostly within other ecotoxicologists?
I think my interactions are mostly with other ecotoxicologists, and I guess that would fit under like environmental as a group. Because ecotoxicology is how toxins impact biological systems, so non-human systems. And then that's extrapolated to ecosystem health. So I guess the eco is like ecosystem. But I do interact with like regular toxicologists. Toxicology, just like plain without anything in front of it, is toxicology on humans. And their work is pretty similar to ours because they work with rodents. So they do experiments with rodents while we do experiments with like fish and frogs and worms and, other non-human organisms. So our work is kind of similar. And actually right now with my thyroid hormone work, I'm collaborating with toxicologists. So they're sending me gland samples from rats. So that'd be, I guess, a collaboration with a non-ecotoxicologist. Yeah, because, rodents and frogs and fish are the experiments that we do and the things we want to look at are similar. It's just the next step of like, what do you extrapolate that to? So a toxicologist would extrapolate that to humans, but we extrapolate it to ecosystem health.
Expand like more about like of what you've done in the past or what you're currently doing, like with your work specifically. In our research, we found that you work with PFAS, but just to give some context for our viewers, PFAS are a complex group of manufactured chemicals that are ingredients in various everyday products. We understand that part of your work has been towards eliminating them in products. So can you tell us a bit more about what they are and how they can be harmful?
Yeah. And my work isn't actually in eliminating them in products necessarily. I mean, I guess in a roundabout way, that would be ideal, because we're basically just experimenting on them to see how toxic they are, and then trying to use that as like a regulatory tool to try to get them phased out. So I guess in a roundabout way, that is true. But back to your question of what they are. So PFAS stands for perfluorinated alkyl substances, and they're basically a class of substances that have carbon fluoride bonds, which is one of the strongest bonds that you can have. And so they don't really break down over time, which is an issue because then they build up in the environment. And they're used in all sorts of things, like any like waterproof coating or like waxy coating on food wrappers. They're used in makeup and lotion, and they're even on like little mouse pad trackers. They're like truly used in most everything. So they are all around, and they are shown to cause cancer and endocrine disruption, which is disrupting like your hormone systems, which is not good, and also reducing immune system efficiency. And there are over 6,000 types of PFAS, which have that same basic carbon fluoride bond structure, but then just like different functional groups on the ends. So they're all similar-ish, and a lot of them haven't been tested for toxicity. So what my group is doing is we are testing certain PFAS to see their effects in order to predict toxicity of other PFAS. So we do that by like looking at the structure and saying like, okay, we tested this one, but like this one has a very similar structure. So we would predict that it would affect organisms in a similar way. And we have like different models and like actual ways of not just being like, this looks like this one. Like we have prediction tools that we're developing, and our current goal kind of as a broader group is to show to regulatory bodies that these tools work and that they can be trusted, so that we don't have to rely on traditional testing methods to test 6,000 plus different chemicals, because that would take many lifetimes over, which is time that we don't have because these chemicals are toxic. So hopefully those tools will be shown to be effective, and then that will kickstart kind of the regulation where we can be like, okay, we found this one's toxic, so like these other 1,000 PFAS, like you can't use anymore. That would be the hope.
Yeah. Okay, that's really nice. It sounds like you guys are like kind of starting a movement with this, proving that they are toxic and should be regulated and more.
Hopefully, yeah.
Anything else you would like to touch on in regards to your experiences in studying STEM or the current work you do, or, you know, general advice for our listeners, the high school population?
I guess I would say if you're interested in science, just keep being interested in it. It's a really rewarding field. There are so many different areas that you can go into. So if you feel like there aren't a lot of paths that you can take, don't get discouraged, because like oh my God, there's like thousands of fields that you can use science in. So if you only know of a few and you're like, these really aren't for me, like you can just stick with it and the opportunities will fall into place. They will present themselves, because there's a lot.
That's really great advice. I hope that our listeners have benefited from that. Like, don't be afraid of chasing, you know, science, even if you don't know specifically what you want to do, because you'll always kind of gravitate towards it, right?
Exactly.
Thank you so much for coming on here. We know how busy you are, and so taking this time out of your day to talk to us has been really beneficial to us, and probably a lot of people are going to listen to this as they start to apply for college or try to decide, you know, what classes they need to take. So yeah, thank you so much. We really appreciate having this conversation with you.
Yeah, thank you so much for having me. I had a lot of fun chatting with you guys.
Yeah, and I hope some of our viewers find that ecotoxicology is an option to go to, because I know, like, for me at least, I'm also interested in science, but like you said, like for some reason it's like, oh, pre-med is the only thing, but there's just like the science field is so like vast and diverse, and there's so many different things you can do with it. So I hope this gave them some insight on what that could be.
Yes, exactly.
Again, thank you so much for joining us.